Sweet. All right. Welcome, ladies and gentlemen. We are live for another live stream here. We're going to cover in this live stream. What I want to do is cover hyperbolas. So we are wrapping up our lesson in conic sections for my class, and we're just getting prepared, ready to take the exam. Right. So then what we're going to do is get into just going over the limits after we're done with hyperbola. But what I wanted to do today is just kind of go over the answers to some of the homework that I have given my students in class. And I will cover writing the equation of a hyperbola, given piece of information, as well as how to graph hyperbolas, understanding how to find the vertices, how to find the foci, how to find the center, and so on and so forth. There are a couple of actual freebies that I also have provided. I have a kind of like a cheat sheet that I created for the writing the equation of any conic section, be it a parabola, an ellipse, or a hyperbola. And I also created a kind of a cheat sheet for graphing the equation. So what those cheat sheets do is they basically just kind of go through it step by step, what you should follow. And then kind of give you, some understanding as far as the different, conic sections and the different important pieces, but then also like just get you the raw information, like what exactly you kind of need to know. So, what I'm going to do is I'm just going to send up a quick link here in the chat, even though it is in the description for those of you that are following along in the replay. I just want to kind of bring in also my kind of two support groups that I have provided, for you guys, so that you can kind of basically follow along, when you guys have questions. And actually, let me just support that whole thing. So when you guys have questions on, really anything that you're covering to your class, or if you guys are looking in for some additional resources for right now, I have opened up the Algebra 2. Algebra 2 as well as pre-calculus that you guys can just go ahead and join. And then there's a lot of good stuff in there as well for you. So there's my Algebra 2. And then let me just go ahead and put in the pre-calculus as well. So for those of any of you guys that you want to go ahead and take a look at it, that information is there for you guys. So, all right. So what I'm going to go and do is just go ahead and get started working on the hyperbolas. And, obviously once I'm done, completed, I have, I think, 6 problems that I'm going to work through. And once I'm done with those 6 problems, what I'll do for you guys is, I'll be more than happy to answer kind of any questions you guys have and go over anything. So let's go ahead and get to the app here. And let's go and take a look at what we have. All right. Okay, so these examples, what they're asking us to do is actually to go ahead and sketch the graph. Now, I just kind of noticed this one's kind of looking a little bit close, so I'm going to for this then. Oh, I'm just going to move that down just a little bit. Okay, so working with this equation, basically what we want to do is when we're looking into graphing, we want to be able to identify the standard form. And we notice that in this first example, the standard form of the hyperbola is not present. It's not equal to 1. So we're going to want to, first of all, make sure that this is set equal to 1. So the first thing I'm going to do is divide by a 36 on both sides. And now by dividing by 36 on both sides, 9 over 36 is going to be 1/4. So therefore I'll have x squared over 4. What I just noticed, I think I'm doing like 3 of the problems you guys did in class. And then negative 4 over 9 is going to be 1/9. So I'll have y squared over 9, and then that is going to equal 1. So now when we're looking at this example, now we can see that this is in standard form. And I'm going to put the standard form here in black. So the standard form of a hyperbola is when we have a horizontal transverse axis, which this is, and I'll explain about that in just a second, is going to be in the form, x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay. So you can see that this is in that format where the x and then minus the h. Now, the reason why the h and the k represent the center, which in this case is going to be 0, 0. So I'm just going to go ahead and write that in there, that the center is going to be located at 0, 0. The next thing is identifying the a squared and the b squared. So we know this is a horizontal transverse axis because a squared is under the x. So therefore, my hyperbola is going to be opening horizontally to the left and to the right. But now that I know what now that I see what the standard form is, and this is written, I can identify that a squared is going to equal 4. Therefore, a is equal to 2. And b squared is equal to 9, therefore b is equal to 3. Now again, given this information, we can identify what c is, and we have to understand the relationship between a, b, and c. And the relationship between a, b, and c for a hyperbola is kind of like the Pythagorean Theorem. It's a squared plus b squared equals c squared. So therefore, we can take that information and say, well, all right, 4 plus 9 is going to be 13, so we could say, c squared is going to equal 13, so therefore c equals the square root of 13. Okay? So now we have a, b, and c, and we have the center, which is h and k. Now we have enough information to go ahead and sketch the graph, and as well as identify the foci, the vertices, as well as the asymptotes. So let's go ahead and I'll try to do my best here to sketch a nice x and y axis. It's actually not too bad, right? It's probably like the best I've done so far. So the center here is at 0, 0. I know that since my a squared is under the x, it's going to have a horizontal transverse axis. So that means that my vertices are going to run along this transverse axis. All right? And they're going to be a distance a away from the center. So we can kind of count here. 1, 2, that's going to be one vertice. And then 1, 2 is going to be your other vertice. So I can say my vertices, which I'll just abbreviate with a v, is going to be at 2, 0 and at -2, 0. Now, what also lies on the transverse axis is your foci. And your foci here, you can see, is square root of 13 away from the center. Well, again, since I'm moving that left and right, I'm just going to add square root of 13 to 0 and subtract it from 0. So my foci is going to be square root of 13, 0, and negative square root of 13, 0. Now again, if we want to estimate this, the square root of 9 is 3, square root of 16 is 4, so square root of 13 is going to be somewhere in between 3 and 4. So actually, let's label these. So that's the center. That is your vertice. So now my foci is going to be between 1, 2, 3, and 4. So we'll call that your foci there. And between 3 and 4, foci. Let me see. I don't know why. My tablet's not zooming in for me, so sorry about that. Yeah, it's not. Yeah, it zooms in manually. That's kind of nice, but I'm not sure why it's not zooming in for me on my tablet, so I'll have to figure it out. All right, so now the next thing we want to do is go ahead and take a look at identifying. Oh, we already have all this. Now we need to identify our asymptotes, because we don't really need to identify the co-vertices. That can help us out, but let's just go and identify the asymptotes. So the equation for the asymptotes when you have a horizontal transverse axis is going to be y equals plus or minus b over a times x minus h plus k. So now I'm just going to plug that information in. So b, in this case, is 3. My a is 2. And then we'll have x minus h, which is 0, and k is 0. So I'll just leave it as y equals plus or minus 3 over 2 times x. All right. Now to sketch our hyperbola, I'm not going to draw the asymptotes. Well, we could go ahead and let's do them as like a blue. So let's actually draw the asymptotes. So we go up 1, 2, 3 over 2, and then down 3 over 2. And what you could see here is there's one asymptote. And then we could also do the negative slope, so that'd be up 3 to the left and down 3 to the right. And this would be our other asymptote. Okay, so notice that the asymptotes intersect at the origin. And then now if I wanted to sketch my graph, they're going to open up towards the foci, and they're going to be approaching your asymptotes. Okay, so there is question number 1 done. Let me just go and check in, take a little break here for myself. Nico Suhona, yes, do you have videos on parabolas? Yes, I do have videos on parabolas, and actually I did a live stream about 2 weeks ago. If you look at my recent live streams, I do have a live stream where I talk about the parabola talk about the focus and the directrix and everything like that. So you can also just go ahead and search YouTube or on my channel, hashtag conics, and there is going to be all of my playlists that I have available in conic sections, which is, quite a few kind of things. Angelique, happy to help you. Thank you. I'm very happy to be here for you and to be able to help you out. And piss on my floor. Thanks, man. I'm happy to help you pass your exam as well. Hey, Jay Nader, good to see you again, man. Glad you could join. All right, so let's go ahead and, come on, Zoom. Let's go ahead and work on the next one. So this one is a parabola that is not at the center, but we can see that remember the formula here is x minus h, y minus k. So we can use this information to be able to have the center is going to be at -1, 2. All right. Now, again, noticing here is this formula, right? That's the standard form. You notice that this is in standard form. I don't need to do anything like I did in this last example as far as rewriting it in standard form. So I can just take this standard form here, identify my a squared, which in this case you can say a squared is equal to 144. So a is equal to 12. B squared in this example is equal to 25. Sorry, I just got to move over the chat so I can see. There you go. Just want to make sure that I'm still in focus. I'm not covering up myself. B squared is going to equal to 25. So therefore B is equal to 5. And then remember the relationship of A, B, and C. A squared plus B squared equals C squared. So when I add 144 plus 25, I get 169. So I could say C squared is equal to 169. And if I remember correctly, square root of 169, which we don't use it that often, is going to be 13. All right. So now let's go ahead and, sketch this graph. And I'm actually going to zoom out so I can use this information. Okay. So now when I'm sketching the graph, I got to plot the center, which is at -1, 2. So I'm going to go -1 up 2. Okay, and that's my center. Now again, notice how my a squared, it's always a squared minus b squared. Notice how a squared is under x. So then again, I have a horizontal transverse axis. Now since my center is off of the x-axis or the x-axis, I'm going to draw a nice little horizontal line just to remind me that my transverse axis is horizontal. And again, what's important about the transverse axle is by looking at this last example, that's where my vertices and foci lie on. So that's why it's kind of important to make sure we have those in there. All right, next one is, now let's go ahead and identify where my vertices are going to be. So my vertices are going to be along this axis, and they're going to be 12 units, which is a, because the distance from your center to your vertices is 12. So it's basically going to be my vertices are going to be at -1 plus or minus 12, 2. So let's actually just figure those points out. So that's going to be -1 plus 12 is 11, 2. And -1 minus 12 is going to be -13, 2. Okay. Now we can plot those points. I guess I can or 11, 2, -13, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then -13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so there's your two vertices. The next thing we want to do is go ahead and identify my foci. And my foci, you can see, are going to be 13 units away. So my foci would be, and again, the foci lies on the transverse axis, is going to be -1 plus or minus 13, 2. So again, that's going to be -1 plus 13 is going to equal my point 12, 2. And then it's going to be -14, 2. Okay. Now in this case, you can see that they're really just one extra point over, right? So it's just an extra point over. That's going to be my foci, and that's going to be this foci. right? Now, the next thing is let's go ahead and identify what the asymptotes are. So again, this is a transverse axis, so I'm going to use the same formula. So when I plug in this formula, I get y equals plus or minus my b, which in this case is 5, over my a, which is 12, times x minus h, so that's going to be x plus 1, and then plus k, which is 2. Now, in the last example, I just decided to graph that because, heck, it's not that hard to go ahead and graph, plus or minus 3/2 y. But when I look at this example, this is not that easy to go ahead and graph. It's not going to be easy to be able to graph plus or minus 5/12 x plus 1, x plus 1, 2. You could rewrite it in slope-intercept form and graph it, but it's not going to be that easy. So one of the things that we can do is create a box with the co-vertices as well as the vertices. So I got to go and find the vertices here real quick. The vertices have a distance of 5 from the center. So what I'm going to do is I'm going to plot these vertices. So let's go. I'm not going to write them down, but I'm just going to plot them. So let's see, it'd be down 1, 2, 3, 4, 5, and then up 5. 1, 2, 3, 4, 5. Okay, so what we can do if we need to sketch the graph of the co-vertices. Now again, I don't have like a ruler stuff, but what we're going to do is we're going to draw a vertical line through the vertices, horizontal lines through the co-vertices, and what that's going to do is that's going to help us identify the asymptotes. Because if we were to graph this, what we would notice is that the asymptotes of this function, or of this conic, transfer through the center as well as the corners of these vertical and horizontal lines. So we're using this as like a little bit of an aid for us to identify the asymptotes. And without actually having to graph this line, we can actually see now where the asymptotes occur. So now when I get to graphing my hyperbola, I can just go ahead and approach those two asymptotes. So it's just a nice little trick. I mean, obviously, if you need to find the equation of the asymptotes, you're going to have to simplify that algebraically. But if you just need to be able to sketch a graph of the asymptotes, that's kind of a nice little way. All right. You know what I think I'm going to do? I am going to cut this out. I'm going to do this one last problem. But if you guys have any kind of questions after I'm done, I'll be more than happy to spend a little time answer your questions. Yes, Jane, you got me on that one, and I'm glad you have notifications, man. I'm glad you're able to come in. So I'm going to do a little Q&A if you guys have any questions after this, if I can help you out with anything you guys have. So Lena says, how can you find symmetrical equation over the x-axis with y equals negative squared plus 3? So how can you find a symmetrical equation? I'm not sure, Lena, what exactly you're asking. Maybe if you can rephrase that. Caitlin says, my finals today. Your videos have helped me understand college algebra so much. Thank you. Well, you're very welcome, Caitlin. I hope you did great on your exam. I'm sure you probably put in a lot of work trying to go back and remember a lot of things. And I do know it is a lot to kind of take in, but hopefully you get to kind of breathe a little bit of sigh of relief, now that you are finished, and you can just kind of rest and relax and, be ready for next school year. Hey, some guy. Hello to you too, man. Let's see. What is the formula for eccentricity of a parabola? Well, the eccentricity, I'm not sure as far as on the parabola, but the eccentricity that are used for a circle and an ellipse is E equals C over A. So E equals C over A, where E represents the eccentricity. I'm not sure if I've gone over that or have anything as far as a parabola for you, but that would be your eccentricity with that. Well, Chi Pang, I'm sorry, I'm not really sure exactly what you need for your mock exam or what exactly math class you're taking or your calculator. I need help with my mock exam math. Well, best thing, I'm not sure if I can help you out with that. Best thing I do is maybe look at some tutorials on YouTube, see if anybody's done anything for you. My voice is very low. Well, thank you for letting me know about that. You're the first person that said something. Let me check. It's I can turn my gain on. Maybe I'll turn. Hello. I don't know. Well, either way, I'll sound. Sorry about that. I'm sorry if it's sounding very low, but I do appreciate you letting me know. I mean, everything looks like it's fine coming here on my end. So, Yeah, it needs my volume. My volume, everything, when I checked it out before I started going live, it was looking, pretty good. So I'm not sure. I'm not sure why it's not sounding high on your end. It's everything on my end is at least showing a good thing. But I can go and speak a little bit closer into my microphone. Maybe that helps out. Seems like that's going better. So just give me maybe a thumbs up, or let me know if that sounds a little bit better. Going from there. All right, let's go ahead and finish up this last problem. Seems like 3 questions is kind of going to be kind of my max here today, and then I'll kind of get back to it later. So I'll finish up this second portion of this on Friday. We'll do that. All right, so in this last equation, again, we realize we have an equation that is not in standard form. So this equation, since this equation is not in standard form, we need to rewrite this equation in standard form. So to rewrite the equation in standard form, we're going to need to complete the square. But before we complete the square, we're going to want to rearrange our variables so our x's and our y's are grouped together. Thank you. Hopefully, just moving the mic helped out. So by grouping these, I'm going to group my 9x squared minus 36x minus 4y squared plus 8y, and then I'm going to add the 4 to the other side, so that's equal to 4. Now, I'm going to want to create the square to create perfect square trinomials. So to go ahead and do that, I have to factor out my coefficients of my squared term. So in this case, I'm going to use some color coding here. I need to factor out a 9x out of those first 2 terms. And actually, I'm going to leave that parenthesis blue. So when I factor out a 9, I'm going to be left with x squared minus 4x. And then here, I'm going to factor out a negative 4. And when I factor out a negative 4 from my y squared, and 8y, I get a negative 2y. And then that's equal to 4. Now, again, the idea of this is so therefore I can now create perfect square trinomials within each of these parentheses. So you see here I have x squared minus 4x. I need to find a value c that is going to create a perfect square trinomial that I can now factor down. So what I'm going to do is I'm going to take my middle term, or my linear term, divide it by 2, and square it. And what that does is that gives me the value that makes that a perfect square. And you'll see why having a perfect square is important. Because when you have a perfect square, what you have is you can rewrite it as a binomial squared, which is in our formulas is exactly what we want. All right? So now I'm going to take these values and I'm going to add them inside the parentheses. But remember, since you're adding them inside the parentheses on one side, you have to add them to the other side. So it's going to look a little bit like this. So 9 times x squared minus 4x, and then I'm going to add 4. But again, I'm going to write this on the other side here right now too. There's that 4 there. Since I'm adding this green 4 on the left side, I got to add the 4 on the right side. But I'm not really adding a 4. I'm adding a 4 that's being multiplied by 9. So that means I need to multiply this 4 by 9. Then we move on to the next one. So then we have a minus 4, and then times y squared minus 2y, and now I'm going to add a 1. So since I'm adding a 1 on the left side, I need to make sure I add a 1 on the right side. However, you notice that we're not just adding a 1 on the left side, we're adding a 1 that's being multiplied by a negative 4. So therefore, I need to multiply this one by a negative 4. And what, again, you guys see here is 4 plus negative 4. Those go to 0, and this equals 36. These perfect square trinomials have now been created they're now perfect square trinomials that I can now factor to binomial squared. So now I have a 9 times x minus 2 squared minus 4 times y minus 1 squared equals 36. Well, again, to write this in standard form, what I'm going to need to do now is divide by 36 on both sides. And when I divide by 36, I get 9 over 36, which is 1/4. So I have an x minus 2 squared over 4. And then 4 divided by 4 over 36 is 1/9. So therefore, that's minus 1 minus 1 squared over 9 equals 1. And now you can see, ladies and gentlemen, that we have this in standard form. Now, again, this is the exact same problem that's in the exact same formula as this. We have our x minus h is listed first, so we could technically think of that as like our positive form here. So now that that's going to be the positive form in this example, what we can do is we can recognize that a squared is the first term, b squared is our second kind of denominator, and since our a is on our x, we're going to have another horizontal transverse axis. So we're doing 3 horizontal transverse axes here. All right, so let's go and write out the items that we can figure out. Brown, I don't use brown very much. So we have our center is going to be at 2, 1. My a squared is equal to 4, and my b squared is equal to 9. Looking at the formula for the relationships of a, b, and c, we can identify that a squared plus b squared equals c squared, so therefore c squared is going to equal 13. So based on this information, I can say a is equal to 2, b is equal to 3, and c is equal to the square root of 13. Okay, so now with all this information, we can go ahead and identify the center. Oh, we actually got the center, which is your HK. We can identify now the vertices and the foci. Is that like the same? It's basically the same as the first example, right? Is that the first example I did? Yeah, it's like the basically exact same thing, except now we have a center, though, that's a little bit different. So our center is now at 2, 1. So I'll try to do this a little bit quicker. So we have a center at 2, 1. There's my center. We have a horizontal transverse axis. That means my vertices and foci are going to be going left and right from here. So let's see here. My center, or my vertices, I'm just going to write them out, are going to be at 2. So we're going to add 2 and subtract 2 from the h coordinate. So therefore, I'm going to have 4, 1 and 0, 1. So let's go and graph those. So you're basically just moving left 2 and then right 2. So that's a vertice, that's a vertice, that was my center. My foci are going to be basically taking the h coordinate of my center and then adding and subtracting the square root of 13 and then keeping 1. Now again, remember, if I wanted to estimate this on the graph, square root of 13 is roughly 3 and some change, right? So we go 1, 2, 3, and it's going to be between 3 and 4. So we'll just estimate right there. And we can go left 3, 1, 2, 3, 3 and some change. All right. Now we want to be able to identify the asymptotes. So the asymptotes is y equals, previously, up there is going to be plus or minus b over, plus or minus b over a. So b in this case is 3 over 2 times x minus h. So that's x minus 2 plus 1. Okay. So now I don't really want to graph that either. So what I'm going to do again is I'm going to find my co-vertices, which is up and down 3. So 1, 2, 3. There's one co-vertice, and then 1, 2, 3. There's my other co-vertice. So I'm going to use the values of my co-vertices to draw a horizontal line. Oops, right here. And then I'm going to draw a vertical line through my vertices to now go ahead and draw my asymptotes, which are going to go through the corners of that box as well as through the center. And it's not the best in the world, but then hopefully we can draw our nice little hyperbola working just like that. Okay, so there you go, ladies and gentlemen. That is basically how you're going to, those are basically how you can graph a hyperbola, as well as identify the vertices and foci and the asymptotes. So I'll see if I have, I got about maybe like 5 minutes. Maybe I was going to go through these problems, but let's just, maybe we'll do those. We'll do that on Friday. So for any of you guys want to join and want to know how to write the equation of a hyperbola, I'll go through all this information on Friday for you guys. All right, so anybody have any questions? Let me just go ahead and come back in the chat and see if there's anything that I have missed. All right, the hyperbola is brown. I have a test in calc. They're 33 minutes, and I need help. Lily, I am sorry. I do not teach Calc 3, so I'd be very, very hard to be able to give you some last-minute things that are really probably going to make any difference in your exam. My best advice would just be just to relax, just do the best. that's all you can really, do at this point. So, just keep on working through it. And, obviously, at least my quickest advice for taking an exam is do the problems that you know how to do first. If you get to a problem and you're like, I don't know what to do or start, skip it, move on to the next problem. When I used to take math exams, what I would do is I would take the exam 4 times. I would take it one time. I'd do all the problems I knew how to do. And then I would actually write down how many numbers I did. Like, let's say, I don't know, 20. And then I'd do all the ones that I felt kind of comfortable in that were a little bit more difficult that I could have made a mistake. And then I kind of wrote those down, or wrote down how many I did that were that kind. And then I did all the problems that were the most difficult, the ones that were going to take the most amount of time that I wasn't confident in. And then I kind of wrote down the number of problems there. And then I took it the 4th time. I'd go back through all the problems again, and I'd just double check, look at my work, make sure I didn't make any mistakes, or, maybe I'd come back to a problem that I was maybe kind of confused on, so on and so forth. And based on doing that, based on the ones I was most confident in, least confident in, and or most confident, semi-confident, and least confident, I could probably guess the grade I was going to get. And I usually did pretty good. I was pretty accurate. If I was pretty comfortable, obviously you can be confident in a problem and get it wrong. You make a mistake that you don't find. And you can obviously be not confident in a problem and not thinking you're doing it right, but end up getting the right answer. So, but when I would do it that way, I would actually calculate my grade to be pretty close to the same. So that's about the best advice I can do within 20 minutes before you take your exam. So best of luck. Keep on working hard. So, Chase says, cool, bro. And I found, okay, Chase, should I take AP Calculus BC? My math wasn't that good in my freshman sophomore year, but I believe I have the aptitude to do well in AP Calc BC. Whatever your name may sure be, it's really up to you. It's, my thing is why do you want to take BC or why do you want to take AB? There's nothing wrong with taking a credit in college or getting different things. So, I think if it's a stretch for you to be taking BC, it might not be the best option unless you have really some deep motivation behind taking the course, because, any AP class is obviously going to, require a lot of effort and a lot of your attention. And, BC is exactly that. It's a tough class. It's going to require a lot from you. But if you don't have much of a mission or a need to earn those BC credits, I would just say take your time then and maybe take it, in college, or maybe take it, I don't know what grade you're in, or take it at another year. But I think one of the issues that we have in education is we always want to pressure students to be taking all these classes earlier, faster, whatever else. And there's really no need. I didn't take calculus until a sophomore in high school. I didn't take calculus until I was a sophomore in college. There's nothing wrong with that. I have a math degree and I took calculus as a sophomore in college. So I didn't get my BC credit. I didn't get my AB credit, but that's perfectly fine. There's nothing wrong with that. There's no need to have to rush through it. And because one of the bigger problems that we see is students are rushed because they feel like they have to complete all these classes so fast and get to the next class, and they're competing with each other and they're completing, things. And what happens is they get to a class like BC or maybe another math class and they realize they don't really have a great understanding of the math, which they thought they did. And then they really start to struggle. And then rather than trying to work through that class and gain back the stuff that they missed, they just kind of feel like they need to quit. There's no other option. So I would just be careful, what you have with, what comes up with that, as far as on your course selection. And again, you can try it. And if it seems like it's not a real fit for you, then maybe wait another year. Joe says, if I got an A in pre-calculus in college, you think I would do well in elementary statistics over the summer? Sure, Joe. I don't see a problem with any connection, not much connection with pre-calculus and statistics. So I would just say, man, give it a shot. It's obviously if you're doing well in pre-calculus, that means you're going to have something, with the number sense. But I think there's enough difference with statistics and pre-calculus or even calculus that, you can do good or bad and still flourish in one of the other courses. All right. Let's see. Danny says, we'll be taking the midterm today about graphing trig functions. Going to watch your vids to review. Awesome, Danny. Well, I have a lot on trig functions, so happy to be able to help you out. Tanya says, my math professor tricked me into thinking this would be on the final exam. Oh, that's not very nice to trick you. Well, we're going to have hyperbolas on our final exam, so that's why I'm covering it. Hold up, bro. Also, my capsule stuck. All right. Brian, well, guys, I think it's about time for me to check out. Dude, it's like AP and arithmetic progression. Is this Algebra 2? Nikita, this could be in Algebra 2. This is something I used to teach in Algebra 2, but I'm actually teaching it right now in my pre-calculus formula, or pre-calculus class. So it is taught a lot of times in Algebra 2 or in pre-calculus. All right. Well, guys, that is it. I am going to end off this live stream, but I do plan on doing another live stream on Friday. So if you guys do have any questions that you want me to cover, or if you want a little bit more information on hyperbolas, then feel free to join in on the next live stream, and I will see you guys there. Take care.